Hi, good morning and a warm welcome to all. Thank you for joining this webinar on leveraging containers for cloud migration, how to ace it, which is conducted by Aspire Systems. I am Kirtika, your host for today. Let me now introduce the speakers. Jyoti Rangarajan. Jyoti has exclusively architected more than 50 plus SaaS solutions across various domains. She provides strategic and technical direction, helping customers move up the value chain by delivering innovative, scalable, out-of-box SaaS solutions. She is a prolific speaker on cloud technologies across various technical forums. Altaf Ali, he is a DevOps architect with 12 plus years of experience taking care of the overall DevOps practice at Aspire and provides end-to-end DevOps solutions including CI/CD, microservices, Kubernetes, and cloud computing. He also drives the initiatives for cloud orchestration and governance-related tools, which results in helping our customers manage both cost and time. Now, let me quickly brief you on what Aspire does. So Aspire Systems is a global technology services firm with expertise in enterprise solutions, digital services, software engineering, testing, and infrastructure services. Aspire works with independent software vendors and some of the world's most innovative enterprises in retail, BFSI, and education verticals. The company currently has over 3,000 plus employees, 150 plus customers globally, and is a CMMI Level 3 certified. And Aspire has a growing presence in the US, UK, India, Middle East, Asia Pacific, and Europe. For the 10th time in a row, Aspire has been selected as the best companies to work for by the Great Place to Work Institute. In today's session, we will be covering the following topics: infrastructure modernization goals and methodologies, pros and cons of pure lift and shift versus containerization and migration, choosing right skill sets for containerization, long-term ROI comparison of containerization versus pure lift and shift, implemented end-to-end platform as containers. We'll be presenting two use cases. So before we dive into the details, there are a few instructions that I would like to share. During the session, if you have any questions, please type them in the questions tab located at the bottom, and we will provide answers during the question and answer session towards the end of the webinar. In case we run out of time and are not able to provide answers to your questions today, we will get back to you via email. Thank you once again for joining the webinar and enjoy the session. Over to you, Jyoti.
Thanks, Kritika. So by 2020, Gartner predicts that less than 5% of enterprise workloads will be running in a true on-premise private clouds. Gartner projects that public cloud services would reach at least $214 billion by 2019 end, an increase by more than 17% over 2018. Public cloud is increasingly popular nowadays due to the various factors that you're seeing. The cost saving being the most prominent factor. Establishing and running a data center is quite expensive. You need to purchase the right equipments and hire technicians to install and manage the center. When you shift to cloud computing, you will only pay for the services and infrastructure that you would use, and hence cloud's pay as you go model provides the best optimal value for money. Better security than on-premise options. Sometimes storing data on the cloud is much safer than storing it on physical servers and data centers. Breaching the security measures on cloud platform is difficult, and hence you're assured of data security. A breach of a security at your premise can lead compromised data security across. So if you have data on the cloud, you can delete any confidential information remotely or move it to a different account very easily. It is much more easier to also recover from an attack in cloud compared to on-premise. The other factor is business agility. IaaS and PaaS services allow you to acquire the required resources at just a click of a button. One need not have to wait for days and plan for months to acquire hardware anymore. And this makes it extremely attractive and responsive to need that changes from time to time of business. Scalability. Now, cloud scalability enables business to meet expected and unexpected demand of business service without the need for a large upfront investment in infrastructure. Cloud migration provides the ability for organizations of every size to alter their plans due to predictable as well as unpredictable fluctuations in business size and needs. Self-service. This is again one of the important factors to choose cloud. The entire cloud model is built to ease automation and self-service. With a self-service cloud, users can very easily access a portal where they can request or configure servers and launch applications. Benefits include the user being able to access storage, applications, and other services without relying on their internal provider doing it for them. Everything is automated to lift burden of the IT department, which would otherwise perform these operations till now manually. There is also transparency, giving consumers direct access to their cloud at their convenience. Now that we have seen the benefits of cloud, let's look at the various migration steps that are involved in it. The first step is initiation or goal setting. In this step, we determine the objectives, develop a preliminary business case, and baseline the success criteria. The next phase is discovery. In this phase, we discover hardware and software configuration in the data center, determine the relationships and dependency of data and also dependency of the applications, and map the applications to the IT infrastructure. The third phase is the assessment and design. Using automated tools, rapidly one could determine cloud readiness of workloads and which workloads make the best candidates for which type of cloud, and also address other mission critical concerns that one may have. Come up with move groups and what application transition approach the workload has to undergo for migration. The application transition approach could be lift and shift, refactor, or re-architecting. Plan and schedule is the next phase. In this, we understand the IT portfolio and application dependencies to zero down on the best fit migration strategy. Scheduling the migration in phases and batches ensures dependencies are taken care without or even minimal disruption to business. The next phase is migration and optimization. In this phase, following the plan and schedule, the actual migration takes place, following which there is a stabilization phase to stabilize the entire migration. The last phase is the optimization. Optimization is not a one-time activity. It happens over a period of time in cycles. This is where various factors such as cost, scale, performance, etc. are optimized. While we modernize, there are three options to choose from. They are lift and shift, re-architecture or re-platforming, and containerization. In lift and shift, the major advantage is there is a very minimal workforce required to move application, and it's very faster migration and deployment. Now, the disadvantage of it is typically it does not take advantage of native features of a cloud platform, and it may cost more to operate in a cloud. Though the initial shift is less effort and cost, your operation cost could be more on cloud. Now, the second approach is the re-architecture or the complete refactor or re-platforming either. In this, the application typically offers higher performance because it makes use of the native cloud architecture and as well as the advantages that cloud offers. And in this methodology, in this migration, applications can be optimized to operate at a very lower cost. Now, the disadvantage of it is it is much higher cost since much of the application needs to change, and it usually is very slow to deploy applications in this model and migrate to cloud. In addition to lift and shift and application refactoring, we now have the option to leverage containers for both new or existing cloud application migrations and development. Only part of the applications are modified, and it offers faster migration and deployment than complete refactoring. and hence it offers a middle ground of both lift and shift and the complete re-architecture and replatforming. In this model of containerization, one gets the most portability, and the cost can also be optimized to a great extent. It solves two obvious and expensive problems: how to provide true application portability among cloud platforms, and how to build cloud applications using standard approaches and architecture patterns. What you're looking at are the different criteria for comparison of these different migration methodologies. Usually application logic and where the data is difficult to separate are ideal for lift and shift. The cost of substantially modifying and refactoring these types of application is prohibitive, and additionally, if the application already runs well on the cloud, there is no compelling reason to refactor it. Or business critical applications that are poorly designed, there is a significant risk lift and shifting them to cloud. Without refactoring, these applications will consume a lot of cloud resource inefficiently, and thus generating a much higher public cloud bill, and may even create performance and stability problems. In this case, given the importance of the application, it is well worth the investment to complete a partial or complete refactor in order to take the full advantage of the cloud platform. To arrive at a decision objectively, parameters need to be derived to evaluate the approach of the application. Usually the following parameters, what you see, are used to evaluate and rate the options. Code portability, the ability to move code from platform to platform, could be to another cloud or otherwise as well. Data portability, the ability to move data from platform to platform or other clouds or even on-prem. Now, cloud native features, the ability to leverage native features or the power of the cloud platform to support better performance. Scalability and application performance, the ability to run application at optimal performance and also offer high elasticity and scale. Data performance, the ability to reach and send data at optimal performance. And application architecture modernization, the ability to leverage services such as microservices within the application, as well as leverage application as set of services that can be consumed by other applications. Governance and security, the ability to provide core governance and security services from within an application. And business agility, the ability to quickly change the application around the needs of the business, or to compress the time to market or the time it takes to get the application into production. Now that we have seen all the criteria, the need of these parameters varies from application to application, and hence you need to arrive at the weightage against these parameters for specific application needs in portfolio. Now, the scorecard here generally assumes a weightage of 1, and then it scores on the various criteria against the different migration methodologies, whether be with containerization or replatforming or re-architecture or lift and shift. If you look at this, there are many factors that aid containerization. Of course, re-architecture and replatforming scores well in certain areas, but then you could see that the portability of code or reuse is quite poor in re-architecture, and it's also higher in container. At the same time, at least matching or being near to performance and other criteria as re-architecture. So, and hence, where one could not get into a full-blown re-architecture or replatforming, they could very well choose containers to attain that middle ground from what you could see here. So this is the assessment decision table. You need to actually weigh your, arrive at a weightage for your application that you have picked for migration, and then assess the score against it. And based on the score, you could very well choose a criteria of whether it could be a lift and shift or what other risks you anticipate against that and so on. So once you fill this, you have a schedule, or you have a migration mode available for each of the application, and then from then on you can go on to the planning phase. Now that we have seen the benefits of container and also compared it with the other migration approaches, now looking on to the support of containers in cloud, public cloud providers offers various options to host containers, which are almost more or same between different cloud providers. And now we would look at the options in AWS. EKS or AWS EKS is the Managed Kubernetes Hosting Environment supported by AWS. If you are already using an on-premise or cloud provider host for Kubernetes, or you're looking to utilize the de facto industry standard for open source orchestration of containers, EKS can provide many benefits of Kubernetes without the operation responsibility of hosting and configuring the Kubernetes environment. Once your EKS cluster is configured, the management, monitoring, and deployment of infrastructure will move away from the custom AWS specific process to the open source Kubernetes process. For example, a majority of the configuration of your cluster and monitoring of your pods will be handled by kubectl. You can prefer EKS if you are utilizing AWS, but also want to keep your infrastructure portability as an option for other cloud providers. You also want to utilize the most flexible and future-proof managed container environment that is certified, which is K8. You also want to ensure open source tools are used as much as possible in your environment. And if you want your developers and operations to be able to determine how your containers are managed. The next option is ECS. First, let me cover the ECS EC2. ECS EC2 is the most AWS specific managed container. If your infrastructure is already built on EC2 and you have defined your own auto-scaling capabilities, ECS may be the most natural fit for you. ECS utilizes EC2 underneath to power its compute resources, and EC2 instances are deployed and managed within your own AWS resources and registered to an ECS cluster that you define. You can prefer, or ECS is more advantage for you if you're already on AWS. You have an existing AWS footprint, such as already defining your VPC, subnets, processes for provisioning and managing EC2 instances, and so on. You have an ops team in place to manage AWS resources. Now moving to ECS Fargate. ECS Fargate is a serverless option for containerization from AWS. Fargate removes the responsibility of provisioning, configuring, and managing EC2 instances by allowing AWS itself to manage the EC2 instances. Fargate completely eliminates the need to manage service, but also puts a requirement of your task definitions to be stateless. Currently, no volume can be attached to the container defined in your task, which eliminates some type of containers such as data stores and other kind of containers requiring persistent storage. You are most likely to use ECS Fargate if you are utilizing AWS already and you may not have an existing VPC. You're not into EC2 maintenance and management. You may not be utilizing ECS and do not want or looking to reduce your operation responsibility on AWS. And if your applications are stateless, majority of your state is either managed through S3, RDS, or other external services for your containers. If these factors are true, then ECS Fargate is a right fit for you. Similar to AWS, Azure also offers AKS, which is a managed Kubernetes, ASF, Azure Service Fabric, and a flavor of serverless, which is ASF Service Fabric Mesh. These are all very similar to the containers offering, which are offered by AWS that we just saw. Next, let's see some of the best practices while migrating to cloud and especially while adopting containers. The first one is infra provision automation. The concept of infrastructure as a code is very similar to programming scripts, which are generally used nowadays to automate IT process in a traditional environment. However, scripts are primarily used to automate a series of static steps that must be repeated numerous times across multiple servers. IAC or infrastructure as a code uses higher level or descriptive language to code more versatile and adaptive provisioning and deployment process. Some of the most adapted IAC engines are Terraform, CloudFormation, Azure ARM templates, Ansible, etc. The code-based infrastructure automation process closely resembles software design practice in which developers carefully control code versions, test iterations, and limit deployment until the software is proven and approved for production. Software developers can themselves use code to provision and deploy service and applications rather than relying on system administrator in a DevOps environment. With the infrastructure completely set up, written as code, it can go through the same version control, automated testing, and other steps of a CI and CD pipeline that developers use for application code. IAC combined with containers abstracts the application from the infrastructure completely. Immutable infrastructures. In a traditional mutable server infrastructure, servers are continuously updated and modified in place. Engineers and administrators working with this kind of infrastructure can SSH into their servers, upgrade or downgrade packages manually, tweak configuration files on a server-to-server basis, and deploy new code directly onto existing servers. In other words, these servers are mutable. They can be changed after they are created. Infrastructure compromised of mutable infrastructures such as mutable servers can itself be called mutable and traditional. And immutable infrastructure is another infrastructure paradigm in which servers are never modified after they are deployed. If something needs to be updated, fixed, or modified in any way, new resources built from a common image with the appropriate changes are provisioned to replace the older ones. After they are validated, they are put into use and old ones are decommissioned. The benefits of an immutable infrastructure include more consistency and reliability in your infrastructure and a simpler, more predictable deployment process. It mitigates or entirely prevents issues that are common in mutable infrastructures like configuration drift and snowflake servers. However, using it efficiently often includes comprehensive deployment automation, fast server provisioning in a cloud computing environment, and solutions for handling stateful or ephemeral data like logs. Service mesh, which is used for inter-service and cluster communication, is a way to control how different parts of an application share data with one another. Unlike other systems for managing this communication, a service mesh is a dedicated infrastructure layer built right into an app. This visible infrastructure layer can document how well or not different parts of an app interact, so it becomes easier to optimize communication and also avoid downtime as an app grows. Modern applications are often broken down in this way as a network of services, each performing a specific business function. In order to execute this function, one service mostly relies on the data from several other services. But what if some services get overloaded with requests like that? And then if with the help of service mesh, it routes requests from one service to the next, optimizing how all the moving parts work together, and it also monitors the same. Centralized configuration management, configuration for all application components, especially in a microservices kind of architecture, is preferred to be stored at one place, a centralized configuration store. When a microservice or an application component needs its configuration, it provides a unique ID, which is nothing but a combination of the name of the microservice and the environment itself. And the centralized config server looks up the configuration and provides the configuration to the respective microservice. In this model, all the configuration is in fact stored in a single place, which is the central configuration store. With this, we have covered the first part of best practices of containers. I hand it over to Alta to take it from here.
Hello all, thanks Jyoti. Okay, to start with, the slide that we are going to talk about is more on the DevOps, CI and CD. So as you all know, the CI/CD is more about having an end-to-end life cycle of code in terms of how DevOps culture, the end-to-end life cycle looks like. In that, to have a CI/CD for the cloud aspect, containerization, the life cycle will have these elements. I mean, starting with the code build and all that, whatever I have given it here, could be like code build and container build, artifact management, configuration management and all that. Let me go one by one, maybe in detail, so that we'll have a more clarity on that part. So before going into a little more detail, so just give you one more note. To have a CI/CD in a cloud, since it is going to be on a different cloud and different tool set and different tech stack together. So this can be achieved by any relevant and right tool set. For example, if it is Amazon, you can even have the end-to-end pipeline implemented using an Amazon pipeline, which is available as a service. And it could also be, if it is Azure, then it can be done by Azure DevOps, or open source, it can be a Jenkins or any relevant tool set, right? So to start with the code build that we are talking about, it is a basic the code build that can be done by any build mechanism. Could be like a Maven or Gradle or Ant, whatever it is, or it could also be the other native build aspect. And coming to a container build is something like that we do it on top of the code build, just to package the source code in a container as a pre-installed state and accept the configurations. Configurations can be added during the boot time to avoid any more like a security aspect. We don't want to feed all the content within the container, like a database password and all that. So that can be externalized and that can be feeded during the boot time of a container. And coming to artifact management, it's more like, okay, now we have a code build and container image which is available, and how we want to manage the code build. It could be a container image, or it could also be the basic build, whatever the Maven build or the .NET build and all that, or any NPM related. So how and where we want to manage the artifact could be like, if it is a container, then it's going to be more on the respective container registry. If it is Amazon, then it's going to be like a ECR, or it could also be Azure registry, or any if it is some other cloud-based, or it could also be something like a Docker registry and all that. And coming to configuration management, having said it needs to be handled to ensure that all the the parameters that we want to externalize it from the containers, that need to be handled as a part of the configuration management. So it can be achieved by various options nowadays. We have a lot of tool sets. Could be like a conf D with a param store, which is a service which we can avail by storing all the contents over Amazon itself. Or even the conf D itself supports all the different backend supports. It could be a console, etcd, or Zookeeper and all that. And again, the same configuration management can also be achieved by kind of Ansible which can pretty much handle the configuration updation part. And coming to a continuous deployment. So now we have done the build part, and we have the artifact which is available, and we also implemented a configuration management and how we want to deploy it, and what kind of a release management or a promotion strategy that we want to put in so that it can be released across multiple environments with a specific criteria, or it could also be done by a specific gatekeeper with the approval mechanism and all that, right? So that's where, like, we are certifying the code to be released across multiple environments from dev to prod. And coming to a continuous testing in between, like the phase which is in detail, we need to talk about a continuous testing, where we want to ensure that there are two types of testing that can be achieved in a CI/CD. One is that whenever any new code changes coming into a continuous integration, let's say more like a feature branch related, pull request and all that, that will eventually go through a frequent continuous testing by having an API tool integration in a Jenkins or any CI tool, whatever we are using it. Or it could also be any, like, functionality level testing by adding, integrating with the UFT based test cases, executions and all that. So that sort of a continuous testing which can be achieved in CI/CD pipeline, so that it will ensure that the code which gets released across, from dev to prod is being tested continuously, and the code is stable enough to be in a prod. And also coming to continuous monitoring. Now let's assume like we have a code which is being released to a production, or maybe in between the systems, could be a the pre-prod environment. So how you want to monitor it, and what kind of a tool that you want to integrate it. Could be a open source, or any enterprise editions, could be like starting with the Nagio till the New Relic, or any APM specific, or it could also be like a hardware related monitoring. You want to monitor what is the memory utilization, CPU, application point of view, synthetic test and all that. So that sort of a continuous monitoring that you need to integrate it with your CI/CD pipeline, right? And also like the feedback mechanism is where like you're going to incorporate back to the life cycle of code, where this is so and so bug being raised and all that. So that's where it will get feedback to a let's say if the project is being managed by Jira, so how you want to track back to all the issues from the productions, and being in a development again and getting them released as a continuous integration model. So that sort of end-to-end CI/CD lifecycle, which can be achieved by a respective tool set for a container. The areas that we really need to worry, or we really need to focus more on that containerization over a cloud, is going to be a configuration management, and also how you want to make the container build to be seamless. And in fact, like some of the options, like people even tend to use it. The build will always happen independent, and they tend to use a mount option in a container. So they would not even need a container build on top of the code build. So it will by default use a network file system to run the latest build. So that sort of options also is pretty much possible, but it depends on case-to-case scenarios. All right. So coming back to one image, how we want to maintain a universal image pattern across all the environment. Let's say like we are doing a container-based implementation over a cloud. At the same time, it should be a universal image. That's the advantage of going as a container, so that you will, whether it is a dev or a prod, will always have a single environment which is being tested back to back, and then be in the production as it was in the dev earlier. So to achieve that, it should be a universal image. When I say universal image, all the parameters, all the application configuration need to be externalized, and more like a dynamic configuration parameter. It can be achieved by having said, it can be achieved in the boot time, more like an entry point where you can define and integrate with a relevant tool set could be like, the good example going to be a const, where it can update all the externalized parameter from the backend system to a application configuration. So, or it could also be achieved by, sourcing them into an environment variable so that it will be used by applications. So that sort of externalizations need to be done in order to have an image up and running across all the environment as a single base image. And as highlighted before, it could also be achieved by having a stateful containers where you can launch the app code as a mount option, but it is more like optional. And in a reality, most of the times people don't prefer to go as a stateful containers. It's good to go as a stateless, and then you can pretty much achieve the same thing over rebuild of the entire container after doing the base code build. And coming back to the pipeline again, in order to achieve the single image across multiple environment, you also need to ensure that you have a proper pipeline design and the promotion strategy and all that in place. For example, if you have a different requirement in multi-stage environment where you would the way that you design a pipeline is required a duplicate build, then it would really make a situation complicated. So you need to ensure that the pipeline that you design from the development or the moment when somebody commit a code into a branch till the production release, how you want to put the promotion strategy and the release management and the pipeline design, which is tightly coupled, and it is going to support you making a single image across multiple environment. And it would by default have a integrated relation to a branching strategy as well. It could be, as you know, like there are various branching strategy with a proven production standard. So that is something again we really need to consider when you want to achieve a single image thing. However, having said, making single image from the development till the production is pretty much recommended, but again it is used the case-to-case scenario. The reason is that it's more like some of the use cases where there are multiple application dependencies where sort of like not a complete microservices, and some of the areas it might even tend to make a scenarios where the multi-build might end up getting created. If you really don't want to skip it, so such cases need to be considered as exceptional use cases. Alright, let's say now we have the proper CI/CD in place, and having said like we are able to achieve the single image across multiple environment. So again, coming back to a continuous monitoring, something that we discussed in the previous slide, it has various options to achieve. In fact, like there are various metrics or stats or the different needs that would require, and we really need to ensure that we collect all the necessary details when we go for a containerization. It shouldn't be as a normal one particular log collection, which will really not going to help much when you want to run something on the production system. To start with, it could be a deployment level monitoring. Whatever you deploy it, or you let Jenkins or any relevant CI tool to automatically deploy. Let's say like you make the development environment automatically get deployed, something gets committed over a developed branch. So if there are any failure notification that really need to be integrated to a monitoring, or that really need to be notified to a relevant people to ensure that something is going wrong in an automated fashion of deployment, right? And also it would also make sense if you have a detailed monitoring, like the application performance monitoring, or it could also be a synthetic API test. Let's say you have some APIs or the applications that really need to be tested by having a necessary tool set as a functionality level test by making an automated way. Could be even achieved for an example like New Relic or any the tools which are available in the market as a SaaS product. It would even make things more easy. So, and coming back to a cluster level monitoring, let's say since it is going to be a container and you're going to run them in an orchestration platform, could be any platform, starting with a containerization like ECS or EKS or a COPS cluster or AKS, whatever it is, but then it's going to be run in a cluster. So how you want to ensure that the cluster is being up and running always throughout the clock? So what kind of a monitoring that you can put in? And also if it is going to be on a virtual machine level layer, let's say the worker node or the agent, wherever you have the load being split. So what kind of a monitoring that it can be applied on a worker node? And it could also help collecting the logs in detail for a better log management that would help your things more easy in terms of log management or a security analysis and a lot of things. And just to bring in one more aspect, the security is something really need to be in place. For example, whatever the log management that I said, it would really make sense adding a security monitoring as well, so that we will have a solid, robust system in place of production, right? And coming back to a container implementation steps. So just to summarize it, whatever we have been through so far, to make the whole lot of things very easy. What you have to do when you want to move a container into a cloud, to start with, do a Docker file and make a build available and set up a cluster and build a CI and build CD. Then how you want to communicate between the services, whatever you want to deploy them, because end of the day it's going to be a service which is going to talk to each other. So what kind of a service to service communication that you want to have it? As Jyoti said, a lot of things are in place like a service mesh and so many things. So what kind of a better implementation that you would like to have it? And then coming back to the monitoring, which is going to help you a lot, keeping an eye on what is happening on the production system or whatever happening on the application level or the hardware and all that. So that is a very high level, the workflow or something that you really need to focus on, having the containers on a cloud. So having said whatever we've been gone through so far, let's have two use cases quickly. Maybe I'll wrap it up. One, from a telecom customer that we worked some time back from a Middle East. They want to have their microservice strategy to be implemented in AWS cloud as a part of their cloud migration initiative. Right? It's basically a Java Spring Boot application. It's something like the numbers I would call it like between 40 to 100 different microservices. So that's something like they have a lot of requirements, since being a microservice they need to have a lot of scaling perspective and some the peak time they would want to scale to a level where it might even go to a 200 different nodes. So considering the requirements, it is something that we could deploy them over a COPS cluster. Might even ask, why didn't we go for EKS? We didn't have that EKS in a available option over Amazon during that time, so we went ahead with the COPS cluster, and we used a configuration management as a confd. And we found that as a better option to go with a container, which provides a lot of better options in creating our own template and easy management and the robust way of working and updating the configuration during the boot up time. So we managed to integrate the confd using the supervisor D, since the container is mean as a single process, right? So having a supervisor D managing more than one process in the boot time in entry point, that really helped us a lot in managing the container configuration management in a better way and keeping all the parameters in the param store. And again, we also considered in a security aspect in encrypting all the necessary and sensitive informations over SSM, and then keeping the plain text as the parameters, right? And then implemented our CI/CD pipelines over Jenkins, which we felt like, we wanted to go with the open source and robust option, since the Jenkins is a better option as always. And we were able to achieve the better agile DevOps end-to-end pipeline implementation, and having a strong release management across multiple environment. And again, since it is a COPS cluster, so we used a Helm to do the deployment, and we managed to automate all the deployment activity. Sorry, starting with it could be an ingress, or it could be a service or a deployment, and all that, including the parameter passing and everything being handled through a Helm package management. And we handle the Helm, in fact, through S3 as artifact management as well. So that's something like, we were able to achieve it. As a result, as mentioned, we had a very, the best, or, the strong release and promotion strategy, which we could implement and help our customer having a seamless workflow from dev to a production. And also, like, we were able to automate the infrastructure activity, which used to take up a hell lot of time earlier for other applications or product suites for the same customers. Since we were using the Jenkins and the Terraform, which really helped us making the end-to-end IAC infra as a code automation, as Jyoti said, like we were able to install the infrastructure from the scratch and then pre-install all the applications, and able to make the one-click provisioning ready for our customers for various environment, which really reduced and helped us making the implementation in a faster manner, right? Moving to a second use case, which is something from a financial group of customers from the Europe. It's basically like, they already had the entire application suite in a monolithic fashion, but then they really wanted to convert them as a microservice and add more element to it. I mean, a lot of features and all that. And as a part of the refactoring, they wanted us to take up and, do the implementation over Amazon Cloud. But then the preference is more on the ECS. The reason they have also used the ECS for other applications earlier. So making it more unique and, being a serverless architecture, we decided to go with the ECS target. And that's something like we were able to achieve. And here the entire pipeline being created and implemented over Azure DevOps. The reason is they were already having Azure DevOps for their entire project management, and also have their source code in hosted over Azure DevOps itself. Hence, we wanted to reuse Azure DevOps for our pipeline development need, and we were able to develop a strong gatekeeper based the promotion strategy with the various the releases by having a proper pipelines over Azure DevOps. And again, having the agent being provisioned within Amazon VPC. Hence, we were able to do all the activities of doing a CloudFormation trigger, or it could be a Helm deployment, and whatever that we really wanted to achieve as a part of the Amazon VPC, we were able to do it. And again, adding one more point here, since it is a ECS, as we know that the Cloud Map has a very strong support to ECS for a service discovery. So we went ahead and implemented a service discovery of Cloud Map, something like that we could achieve through external DNS, which we were were able to update each and every services, whatever gets exposed or deployed as a part of the deployment, automatically gets updated by external DNS to a Cloud Map, which we were able to use it as a service discovery. And part of the implementation, I would say, like, we were able to automate the entire pipeline creation as a dynamic. We externalized maximum parameter so that the same pipeline we're able to use by multiple other applications. Something like, let's say you have a new application coming and you want to implement a CI and CD. so that it's not going to take any difficulties. All you have to do is that passing the right parameters and doing a one click with the YAML as in parameters. So that would take you provisioning the end-to-end CI/CD over Azure DevOps. So that sort of implementation that we could do it and add a more value to our customer. And yeah, I mean that results. This is the kind of activity that we were able to do it for two different customers. In fact, these are part of a cloud migration initiative from our customer itself, and they decided to go as a microservice architecture in a container model. So that's all about having a end-to-end CI/CD and what are all the other elements that we could add as a part of the containerization over a cloud. Over to you, Kritika. Yeah.
Thank you, Altaf. So we have a few questions from the audience. So the first one is, does an EKS support serverless too? Jyoti, would you like to take this up?
Yeah, EKS does not support serverless. EKS is a managed Kubernetes. What you get is a managed master node. The worker nodes are something that you would have to manage and maintain yourself. So the load that it offloads from your work is maintaining and managing the master node.
So we have another question. Which container platform and cloud would you recommend?
It completely depends on your affinity, I would say, towards a provider. Mostly AWS and Azure, if you compare, they offer almost the same kind of services, right? So from a feature perspective, you wouldn't really get a lot of difference between these services. Now, between the different container platforms, like say if you move towards AWS, there are different options that we discussed, like ECS, EC2, ECS, Fargate, and EKS. The most preferred one that I would actually, what I have seen in my experience is EKS. That's majorly because, as we discussed, every customer also wants to keep a level of option open for reporting into another cloud provider later on and not getting tied on to a vendor, right? So this is the main reason why they do not want to get tied on to ECS, which is a AWS specific container offering. Now EKS, because it's the base is Kubernetes. Kubernetes is the most used container, I would say, be it on-premise as well, and hence the credibility of Kubernetes makes it compelling even to be used in AWS environments.
So we have another question. What kind of workload is best suited for containers?
Yeah, so when it comes to picking an app which is best fit for containers, if the app is decomposed to multiple application components, right? So that's, I mean, more or less like a microservices architecture. That's the best fit for containers. Also, there needs to be a need for the application to be portable, right? If your app is pretty much in a sustenance mode and you do not want to, I mean, you're very sure that it is not going to be ported to other environment at all, then you don't really need the benefit. And then similarly, scalability is a factor as well. If you want to scale out and get that benefit from containers, you should be looking at that as well. So in a nutshell, microservices are best fit. If you want a lot of code portability, then container is the best fit. And scalability, you would be able to achieve even without containers, but then hosting it in containers offers scalability as well.
So this brings us to the end of the webinar. I would like to thank Jyoti and Altaf for coming up with this interesting presentation and sharing their knowledge on the importance of using containers for cloud migration and the comparison of lift and shift approach with containerization along with the use case. I am sure this session was very useful for all. In case of any queries, please do email us and we would be glad to assist you. Thank you all on behalf of Aspire Systems for joining us. Have a great day.